Good morning, everyone, and thank you very much for coming to this session. We're going to be talking about IoT predictions for 2019 and beyond, putting data at the heart of your IoT strategy. My name is Paul Miller. I'm a senior analyst from Forrester in the UK. I'm going to talk first and share some Forrester data and some Forrester perspectives on the use of IoT. And I'll then hand over to Dinesh, who's sitting at the front there from Cloudera, who will present some of Cloudera's perspectives, and then we'll have time at the end for questions to both of us, time for us to violently disagree with one another, and we'll see how it goes. So if you have questions, save them up for the end, please. So firstly, my bit. As I said, Paul Miller, a senior analyst from Forrester, based in the UK. I spend a lot of time at the moment looking at the digital manufacturing Industry 4.0 space, and IoT clearly is a large part of what's going on there. As we look at the industrial and manufacturing space, we're seeing a real shift in the way that organizations build products and think about those products. And we can look at this in the automotive sector as one example. Think back 100 years or thereabouts to Henry Ford and the Model T Ford. Now, Ford did not invent the motor car. Ford did not invent the production line. But what Ford did was bring together existing ideas, existing processes, and existing ways of working to bring about massive standardization, to drive down cost, to drive up quality, and to make this existing invention, the motor car, widely available to a growing audience of potential customers. And he standardized everything, right down, initially at least, to the color. Any color you want, so long as it's black. Fast forward to today, and staying in the automotive sector, things have changed. A modern car manufacturer like BMW in this case, or Ford or Volkswagen or any of the others, still want the same economies of scale that Ford was chasing a century ago. They still want the same standardization, quality control, and accessibility that Ford was chasing a century ago. But they also want to enable massive choice in their customers. Change the wheels, change the color, change the specification of the stereo system, change the type of wood used in the wood trim of the interior. So much so that in a BMW factory in Germany, of 500,000 units coming off that production line, only 2 are the same. And yet, still chasing the standardization, the quality, and the consistency, and all the rest of it that Ford was after a century ago. So to deliver on this, BMW and their competitors need to do a lot of things. And part of what drives this ability to deliver massive choice is digitization and sensors everywhere. Measuring how cars move through the production line, measuring how tools are being used to build those cars, measuring how workers and components are moving around the space. IoT taken to extremes. So as we look at Forrester data on how IoT is being adopted across a range of industrial sectors, we can see from this data here that the construction and engineering space is the one in which IoT is being adopted most aggressively at the moment. 55% of respondents in the construction and engineering sectors saying they're using IoT today. As we move down to industrial products and sort of the manufacturing space, like the cars we were just looking at, current adoption is a little lower, only 45% actively using these capabilities today, but almost a third planning to do so in the coming 12 months. So we can see growing interest, growing adoption across the board in these industrial sectors. And it's important as we talk about IoT to recognize that it can be used for a lot of different things. IoT, a connected sensor, the ability to get data off something, can be used for a lot of different things. And at Forrester, we talk about 3 different broad use cases for IoT. Firstly, designing connected products. So going through the process of understanding how a product you've perhaps made for a century or more is going to change once you put a connection into it. So instead of just selling a washing machine or a dishwasher or a cooker or a fridge, what happens when you're selling a connected dishwasher, fridge, washing machine, or whatever? Sometimes nothing of any value happens. Sometimes it's just a gimmick. Sometimes it's just a way to sell a more expensive version of a product to a gullible consumer. Sometimes, though, it completely changes the model. We're talking to one maker of white goods here in Europe who've made washing machines for 100 years and sold them to consumers across Europe for 100 years. They're now very seriously considering not doing that anymore. Instead, they're going to give those washing machines away and effectively charge by the load. It's a very different model, and it requires them to think about the product completely differently. Because if you are selling a washing machine to a consumer on an island off the north coast of Scotland, it's a single sale. It's 300, 400, 500 pounds. The money is spent, and the consumer takes the washing machine. If that washing machine breaks, it's not your problem. It's their problem. You don't care. If you're delivering the service of charging by the load, it's a very different proposition. If that washing machine breaks down, sending an engineer is your problem. If that washing machine breaks down, getting spare parts to the Shetland Islands is your problem. And so you build the product differently. You build the product better. You use tighter tolerances. You use more expensive components. And so this thinking about a service-based business model goes all the way back into the design and construction of the initial product. We then see a second group, those looking to operate connected business processes. And they're the ones who are starting to think about shifting from selling a product to delivering a service. Kaeser Compressor, for example, in Germany, who make compressed air machines that are used on building sites, in hospitals, and elsewhere throughout the country. And they are going through this shift as well, and thinking very seriously about effectively selling compressed air by the litre. So things like consumables become their problem. And it's a very different business model. The third phase, consuming connected insights. And that's where you're actually taking the data coming off all these connected devices and using that to offer a slightly different, a different value stream and a different business model to your customers entirely. And we see examples of this in, for example, the weather company, gathering data from connected sensors and selling that on to third parties. We're seeing some interesting experiments in sort of the blockchain space here as well, where car manufacturers, for example, are experimenting, and it's very early, but experimenting with things like the rain sensors on your car. And when the rain sensor activates the windscreen wipers, sending that information to someone else and saying, 70% of the cars driving through Barcelona this morning activated their rain sensors. That probably means it's raining. Sell that information on to others to make use of that information. Early days, not totally sure there's a business model there yet, but a number of the car manufacturers are actively experimenting there. We see IoT addressing a wide range of use cases. Some of them apply to most industries, and this is some work some colleagues of mine did on something called the Internet of Things heat map. And these are the use cases that apply to almost every industry. And you can see, for example, things like building and facility management in the top left-hand corner there, being quite common, quite popular across most industries. Energy management, another one where IoT is being quite widely used. As we look, though, at some of the the use cases for IoT that are more industry dependent, things start to look quite different. So in the primary manufacturing sector, for example, the far left-hand column, things like asset management, things like predictive maintenance, things like inventory and supply chain management become very obvious use cases for IoT. Things like track and trace down at the bottom there. Less popular at the moment in that sector, but of more interest to people like retailers and wholesalers, logistics companies, obviously, and then some of the others. But we're seeing quite a spread of different use cases. And I think the important thing here is that there's a tendency to talk about IoT as a single uniform thing for all industries and all use cases. And that really isn't true. There are pockets of interest, pockets of value, and it's important to understand those and understand why you're considering IoT for a particular use case in a particular industry. We've done some forecasting work to look at the way in which these different use cases are going to grow. At the moment, the single biggest category of IoT investment is in the inventory and supply chain space. It's worth about $44 billion globally at the moment. That's use of IoT in that space. And expected to grow to about $113 billion by 2022. But the sector that's going to grow the fastest at the moment looks to be the track and trace use case, which, as we saw previously on the heat map, is being used across a range of industry verticals. But IoT makes perfect sense here. Small, low-powered sensors allowing you to understand where goods are in the supply chain, allowing you to understand where they are in the delivery process. But not just that, looking beyond that to start to offer some new and interesting business models. So in the cold chain space, for example, using sensors to track the fact that medicines or perishable goods are being shipped within tolerances, within the temperature bounds you set, within the humidity bounds you set, within the vibration bounds you set throughout the supply chain. And then being able to proactively take action if something goes wrong. So instead of waiting until your very expensive, very fragile medicines reach their destination, opening the box and saying, oh, it's spoiled, that's not very good. It's too late by that point. Acting ahead of time, as soon as the sensors are out of bounds, and saying, actually, let's declare this shipment spoiled, let's order a new shipment straight away, and let's automatically make an insurance payout. No need to wait till the goods reach their destination, no need to fill in a million forms, just act. And we're seeing some very interesting use cases there. Edge, and Dinesh is going to talk about edge in a moment. Edge is another of those terms that's being massively overhyped, massively overused, and again, there's this idea that edge is this homogeneous thing and they're all the same. Again, here in the IoT context, there are different kinds of edge, different use cases for edge. And the simplest of those is what we're calling the sensing edge. Cameras, sensors that are out there on wind turbines, on your trucks as they move through the supply chain, cameras watching security doors, all these types of deployment, where basically the edge device is simply gathering data. It's not doing anything with it at all, other than sending it to someone else. The actuating edge is also simple, but is completely different. The actuating edge is doing something. It's not gathering any data itself. It might be an electronic lock on a door. And the actuating edge, an instruction arrives saying, unlock the door, and the door unlocks. It's not gathering any data. Or it might be a motor on a wind farm. that says turn the wind farm 3 degrees to the right, and it just does it. The stateful edge is an edge that recognizes that connections may be intermittent and that the connection back to base may drop from time to time, and so it has to have the ability to store data locally or to take limited action locally without control from base. The one that's perhaps probably most interesting to this audience is the fourth, the autonomous edge. And this is an edge that has the ability to sense its surroundings, the ability to take action, and the ability to do all of this, or most of this, itself. So you're looking here at things like edge servers and edge processors that have the computing power and the intelligence to actually do something. But this, at the moment, is a tiny, tiny fraction of the edge use cases. And a lot of the vendors in this space, particularly the hardware vendors in this space, focus all of their attention on the autonomous edge. Whereas actually it's probably 5, 10% of the edge use cases we're seeing in the wild at the moment. As we look at IoT in the industrial space, and particularly IoT in the context of data in the industrial space, we see 3 broad use cases. And the first of them at the moment is by far the most common. Simple asset monitoring and control. Simply using IoT to understand an existing process or workflow. Where is my truck? Is my wind turbine turning? Is the machine on the production line doing whatever it is it's meant to do? And some limited control, some limited ability to turn it on or off. That's the most common, by far. The one where all the attention is, and the one where all the noise is in the market, is around prediction and action. Gathering data from these existing processes, gathering data from these existing workflows, and using it to actually start anticipating the next action. So gathering data from all the trains in your fleet or all the trucks in your fleet, and using that to predict when the next one is likely to fail. And then the third phase, and we're not quite there yet in most cases, is using IoT to drive these new business models. Things like the washing machine manufacturer I was mentioning earlier. Very early days, but lots of interest. So, mostly asset monitoring and control, most of the hype, prediction and action, the long-term potential is in these new business models. And just to look very quickly at one example of each. So in the asset monitoring space, for example, in medicine manufacturing again, using IoT, using sensors on the production line to track ingredients as they come into those medicines and to track the environment around them. What was the humidity? What was the temperature? What were the level of particulates in the atmosphere as these medicines were being assembled? And using all of that to demonstrate compliance and also sometimes to accelerate product recalls. So you discover that a batch of medicine is spoiled, and you can very quickly go back and say, these were the contributing factors, and these are the batches of medicine that are therefore going to be affected. Let's recall them quickly. And we're seeing lots of examples in medicine, in food, and in some other production processes where this ability is being used to make product recalls much narrower, much more specific, and therefore much less damaging to brand and profitability. Prediction. One example from an island off the north coast of Norway. This is the world's most northerly wind farm. It's inside the Arctic Circle. And here, things like ice become a real problem. The blades of the turbines ice up. Engineers turn up to fix them, and the ice falls off the blade and kills people. And that's real. It happens. Here, the turbine manufacturer has a control room in Germany that's monitoring this wind farm off the north coast of Norway. And there are sensors on all of the turbines measuring motors, wind shear, wear on parts, a whole variety of different factors being measured. And all of this is being used for predictive maintenance use cases to allow the remote operators to dispatch engineers when they're needed, but only when they're needed. They're trying to get away from sending engineers out on a regular cycle. Once a month or once a week, the engineer visits and checks everything, because that's expensive, it's dangerous, it's wasteful. So instead, gathering data from the way these turbines are actually operating and using that to predict when parts are going to fail, dispatching engineers with the right part at the time it's needed to replace a component before it wears out to keep the wind farm operating. And we see, once the connection is put in place for something like a wind farm, you begin to open up a whole range of other use cases and other businesses as well. So the predictive maintenance use case at the top there is the reason for putting the connections and the sensors in the first place. But they're now beginning to use it for a whole range of other use cases around capacity forecasting. Pull in weather data as well, and weather forecasting data, and begin to anticipate how much power that particular wind farm can generate tomorrow, or at the weekend, or maybe even next week. And then use that to start balancing the grid, ramping down the use of conventional power sources because you're confident that your renewables can take up the slack. The final the final example, new business models. And this is one of the most interesting ones we're seeing at the moment. This is Hitachi building new trains in the UK. For anyone who's traveled on UK trains, can't come too soon. Hitachi is building new trains for 2 main routes in the UK. These trains will be owned and operated by Hitachi and their partners for nearly 30 years. There are 3,500 sensors on every train, measuring everything: brakes, vibration, temperature, humidity, whether the bins are full or not. All of these things are being measured. And all of these readings, all of this data goes into the underlying business model. Hitachi only gets paid when a train completes a journey on time and within KPIs. So the train has to arrive on time. The train has to arrive with a certain comfort level. The train has to arrive with a certain loading level. If all of these things are true, Hitachi and their partners get some money for that journey. If those things aren't true, Hitachi and their partners don't get any money for that journey. And so for Hitachi, it's obviously very important that their trains complete journeys within KPI. And they're using those 3,500 sensors and all the data from them to build very detailed predictive models about how all those components in the system will perform, so that you can ensure that a train that's likely to fail is swapped out before it fails, so that a bin that is almost full is emptied before it's too full. And at the moment, these trains are only just coming into the service. So the model is being tuned as the trains go through testing. It'll be very interesting to see if they've got the numbers right. So just to finish off, my last slide. We looked at IoT in the industrial space as part of one of Forrester's waves last year. And a few things came out as very clear, very important from that process. Firstly, 18 months ago, 2 years ago, most industrial manufacturers you would speak to would say, we're never allowing this data out of our factory. All of the IoT, all of the prediction, all of the system management has to happen in the factory. Over my dead body, is it going anywhere else? That has changed. Over the last year or so, the conversation is very much shifting. There's a very clear recognition now that cloud is part of the story. There are very few factories that say everything can go to the public cloud. But equally, there are very few now saying nothing can. And so there's a shift going on there. Analytics, in all its various forms, is a core component now of these IoT platforms in the industrial space. When a colleague of mine first looked at them nearly 3 years ago now, she described analytics in IoT platforms as an emerging category. When we did the work towards the end of last year, all of the vendors had something to say about analytics. Some of them were good, some of them had work to do, but they were all very much actively and aggressively heading in this direction, either through partnership or through acquisition. And the other piece is this notion of the digital twin, building simulations of real-world products and then using data from IoT sensors and other inputs to simulate what's likely to happen in the real world. This is important for remote operation, important for predictive maintenance and predictive scheduling, and a range of other use cases. And again, all of the vendors in this space, making very aggressive plans to improve their capabilities in this space. And with that, I shall hand over to Dinesh. And there'll be time for questions at the end. Thank you.
Thank you, Paul. I'll keep it brief. I want to take a step back and say, okay, fantastic trends happening. We live in exciting times, definitely. So lots and lots of really exciting use cases going on. I talk to customers and partners on a daily basis that are talking about fantastic IoT use cases. So I want to make sure that we highlight some of the key trends that we are seeing in the market out there. Mostly like my perspective on this. One is like the multi-locational data storage. I mean, we talked about the edge, right? So the edge is definitely growing to be more and more significant. People are trying to avoid round trips. They want to get the intelligence right there at the edge. They want to have action happening right there. So which means then the need for having storage capabilities right at the device level or near the gateways or near the edge is more and more becoming prominent. We talk to airline engine manufacturers that are talking about embedding hundreds of agents, edge agents in there to monitor different sensors and all that. And the reality in those kinds of use cases is that the flight is actually flying from like one city to another. And while it is doing that, the sensors are like generating all this data and the agents are capturing all the stuff, but there is no way to transmit that to ground base right then and there. There is like a limitation on what can be transmitted at certain points in time, which means there is a need for storage right there at the edge to be able to store that locally. And then when their flight actually lands at an airport, there is a need for synchronization and everything, right? So that kind of multi-locational storage, which starts at the edge, has all kinds of tentacles reaching out into on-premises as well as cloud and hybrid architectures, is getting more and more prominent, more and more relevant. I think that's something that needs to be addressed. In the context of edge intelligence, meaning the edge being more smarter, the edge wanting to have the capabilities of maybe having a local machine learning model or something like that, that allows it to do local data scoring and to be able to say, yes, I understand what this data is, I can act upon it right there without having to go back to my enterprise, without having to go back to the data lake and make those decisions, is something that we see churning up pretty fast. The other trend is the autonomous edge. I mean, Paul touched on it, very important thing, and we see all types of connected cars use cases popping up. I own an electric vehicle, and the electric vehicle generates data from its hundreds of sensors that are out there. And I get an email which says, every month, which says, Dinesh, this is how much you have driven using the car. This is how many times you've actually sped up beyond like 75 miles an hour. This is how many times you've actually hit the car at the brakes at so many different times, right? So it measures every single thing, which is freaky, but at the same time, all this data is being captured. And the reality is the more the electric car becomes autonomous, then these kinds of data metrics become more inherent at the edge itself. The edge becomes more smarter. It needs to understand and detect, what is a signal, what is a, car in front of it, what is a pedestrian that is crossing there. To be able to recognize that and to be able to act upon it is where the round tripping is not there. It is more action happening right there at the edge, right? So the autonomous edge brings in the notion of device autonomy, more and more to the IoT use cases. The other aspect is machine learning models, right? So we have one notion which says there is data that is being generated here, but the other notion that the more and more data you collect, that is helping me build better machine learning models. So your ML models are being refined at the enterprise, and that ML model needs to be, again, made available to the edge, making it known that, okay, now I understand what this data actually means. I can correlate patterns. I can figure out where it needs to go, and based on which corrective actionable intelligence can be delivered as well. So that's something that needs to be emphasized. Talking about trains, one of the other use cases that you talk about is the positive train control thing, where sensors on the train basically detect another train coming on the opposite direction on the same track, and to be able to apply brakes without having any kind of manual intervention. So this is an act that was passed, and this is something that all different railway companies are implementing. But that again goes back to how intelligent this device autonomy and the intelligence happening at the edge is relevant. The other interesting trend that I'm seeing is images, right? So it's not structured data alone when it comes to IoT. It's a lot of unstructured data. So cameras and images that are being captured. We have read about stories like where they caught somebody in a massive crowd of 60,000 people in a China square because of facial recognition that they were able to run across the CCTV cameras, and they were able to instantly pinpoint and say that's the guy right there that we need, right? So they were able to pick him up. That is transforming not just from a criminal safety kind of a use case, but also into scenarios like trucks where cameras mounted in front of the drivers that are monitoring the drivers, understanding how many times they actually take their eyes off the road, to grab a coffee cup or maybe adjust the radio, or maybe even fatigue. If they start looking sleepy, then the camera instantaneously recognizes that and says, Bob, pull over the truck, time to take a break, right? So that's the kind of connectivity that we are talking about to image recognition, to IoT, to instant actions that need to be delivered at the edge. The other trend is robotics, right? I mean, this is without saying something that we are seeing emerging really, really high. And robotics in the context of retail is also something very powerful. This is a screenshot of an actual robot scanning shelves for products and stuff at a Walmart. So Walmart is deploying these kinds of robots to scan shelves and say which products are up there, which needs replenishment. So this goes to the next level of saying automation, where the robots themselves understand, okay, these products are out or low on inventory. I need to order that. So triggering off an alert to vendors, and the vendors automatically replenishing it. So this kind of automated inventory management is possible with robots and IoT sensors and everything in there. And again, talking about retail, you could talk about smart shelves. You talk about the stores that Amazon is putting out with touchless commerce, where people walk out of the goods and your credit card is automatically charged without having to interface with a clerk. So those kinds of trends are also definitely happening. The fifth trend I want to talk about is IoT and blockchain. Paul touched on it as well. And this is something that we see even amongst our customer base, right? I work at Cloudera, and one of our customers is Trimble. And what Trimble does is this fantastic use case around logistics and fleet management and shipping. They have over 2,000 plus customers. And what they built out was this as-a-service model for transportation management, where they provide single central usage for all their 2,000 customers when somebody has to bid on a particular offer. So somebody says, I want to ship this container from point A to point B, and multiple customers start bidding on that particular offer. Now, Trimble not only provides this visibility, but it is able to incorporate data from customers, from partners, from ecosystem, data points, from enterprise sources, from IoT devices, ingesting all this data, and to be able to make it immutable. Because some of the requirements in this kind of an industry is to make sure that the data is protected, that it's trustable, and there are no duplicates and all that. So having a blockchain under the hood, making it as the immutable source of truth was essential. But the reality is to make sure that as you ingest data from multiple sources, to be creating that golden record that only goes into the blockchain. Not all data goes into the blockchain. So that is also something that is emerging. But the other types of IoT and blockchain convergence that I'm also seeing is where people are saying there is more and more data that is available, data marketplaces. I'm building out like ML models, for example, like connected cars, for example, right? So these types of IoT data needs to be made available as well for purchasing by other enterprises that are interested in that particular data, which leads me to this sixth trend, which is the emergence of data marketplaces. This is a favorite concept of mine. I firmly believe in it, that we are all sitting on like gold mines of data, and every enterprise is trying to monetize on it. And if not now, tomorrow is like something that people are trying to do that, right? We talk about convergence of connected car industries and insurance industries, where the data that I was earlier saying, how I drive, that my car is able to like track, is data that can be made available to the insurance companies, where that company could say, you are driving great, let me give you like a 10% good driver discount, or you suck at driving, let me put like a 15% penalty on your driving, right? So that kind of correlation is possible, where data sharing enables these kinds of business models. And that is what we are headed towards. We already have a customer called Arity, which is a spinoff from Allstate, and they do this today. They do this using our technology to like ingest data, but at the same time be able to provide those kinds of intelligent real-time codes on data that is being captured about drivers, how they drive and all that. And the need for marketplaces is to make sure that this sharing across ecosystems is very essential. And this goes across like multiple other areas as well, not just insurance and automotive. And IoT will be a very key part of it. There are companies out in Europe like IOTA, which relies on the Ocean protocol and all that, where they kind of leverage IoT devices, data, that streams of data that are coming in from IoT devices, to be made available through a blockchain protocol. So you get immutability, knowing that it came from that particular source of truth, and also the fact that available through a marketplace, you can also purchase that stream of data to enhance your enterprise. Maybe it's a machine learning model that you're enriching or something like that, right? So that kind of model building capability is possible when you have IoT and data marketplaces and these kinds of gold mines of data converging together. So I kind of ran through because I wanted to leave some time for questions as well. But that's kind of like where we see a lot of these trends happening. I mean, beyond some of the more classical use cases that Paul touched on around like predictive maintenance, asset tracking, patient monitoring, and whatnot, right? I mean, we see so many dozens of use cases like that across our customer base. But the trends in terms of where things are headed, some of the ones that I personally like, I just highlighted that. So Paul, why don't you come on stage? Maybe there are some questions that people might have for you.
Or
more than me. More than me.
Any questions, anyone? When's lunch?
Yeah, that's the next thing. Yeah, Andy.
What IoT use cases are you most excited about in the near-term future?
Personally, I get most interested in the new business model opportunities, and that's where a lot of my research work is being done at the moment. Looking at the ways that an industrial organization, whatever it may be, is using IoT and using the data from those devices to begin to think about its relationship with its customers differently. The Hitachi Trains example, Caser compressor, the unnamed washing machine manufacturer. We're seeing lots and lots of these examples. And working through the implications of that for the broader business is what tends to get me most interested.
I'll pull something off of the headlines, right? I mean, the air crash that just happened, and we are like trying to understand, what went wrong. There are like 2 similar airplane crashes that happened, and we are talking about sensor data here. There are thousands of moving parts there, so many different sensors there. Somebody did not do the correlation to figure out what went wrong there, and that's an opportunity that somebody needs to take up and say, here's how I can harvest that IoT data, provide that real-time intelligence, and say, this is how you solve that problem. So the opportunities are like amazing. Any other questions? Yes?
You mentioned the data marketplace.
Mm-hmm.
Have you found any which actually work? I keep looking for some, but they don't really work yet. The idea is great, but have you found something which actually works, like, I don't know, eBay or something like that?
No, so there are plenty of public data marketplaces already there. Amazon including AWS. If you just search for AWS, data, there is like so much public data that is already available. So the challenge with data marketplaces is not about making the data available. It's about like how do you control the authenticity and the security of the data, right? So public data is like easy to handle with. You can go to a courthouse, you can purchase data, you can do that. And the same thing is now made available online, so data marketplaces are like right there. But when it comes to ecosystem data, like car example, or maybe pharmaceutical example, or something like that, where somebody needs to ingest all the data to run trials, medical trials and all that, that's kind of sensitive data. You cannot just expose it out there and put it out there. You want to be able to make sure that there is protection around the data, there is governance around the data, that there is lineage tracking to ensure that all that streaming data is coming from the original source and it's not being tainted or tampered with. That's where the real challenges are. And that's why I wrote a few series of blog posts around how data marketplaces should be driven by blockchains, making it more trustworthy. So that's where some of these things like IOTA and all these other companies are investing in. They're coming out with newer models to ensure that the data is authentic, that the data is more secure and all that. So it's still not there. But again, as I see from a trending standpoint, something that will eventually emerge.
One of my colleagues, Jennifer Bellasson, spends a lot of her time looking at data markets and data monetization. And she says she's always asked by clients, what is my data worth? And her answer to all of them is nothing. Your data on its own is just a cost. It's what you do with it.
It's what you do with it.
And building the networks of trust, the networks of value, is hard. Before I joined Forrester, I did a series of podcasts looking at data markets of various kinds. And I was looking back at it last week. Almost every one of the companies I spoke to no longer exists because they couldn't get the economics right. Weather company would be one good example of one that is managing this, pulling in data from consumer weather stations across the world and adding value, adding a stamp of quality and trust and authenticity to that, and then monetizing the data out in various other ways, including in IoT use cases.
Yeah.
But yeah, few and far between at the moment, but I would agree that there is an opportunity here if you can bring the costs and the value and the trust and the networks together in a way that makes sense.
It's more about the tinier ecosystems, which is where it'll emerge. It'll not be big bang kind of approach. It'll be more like within 2 or 3 companies or within a particular vertical. That's where you'll start these things emerging.
Another one, of course, is here. The mapping company that was part of Nokia and is now owned by the big German automotive manufacturers started off basically for in-car mapping and is now doing a whole range of other things associated with that spatial data.
So the person at the door is showing me all kinds of signs to kill this session right now. So thank you so much for being here. Appreciate
Thank you all.
it.